All right, so we are starting section 9.3. It's vertex form. It's just a different way or different shape of an equation, and it tells you different things. We're used to standard form. We're going to be learning about vertex form. Before we begin the lesson, let's just do the class opener. Here it is. Go ahead and graph this standard form quadratic trinomial equation the way you know how, right? Step 1, find the vertex. Step 2, draw your axis of symmetry. Step 3, find more points either by using the pattern or an XY table. Step 1, as you can see on the side board, is to find the vertex. Everybody should know that the first thing to do is find the vertex, and we find that vertex by using x equals negative b over 2 times a. And when you use that formula, please use parentheses when you plug in the b and the a value. What is the b value? Negative 2. What's the a value?
Negative 4.
Negative 1. What's the c value? Negative 1. So we don't even use c. We're just using b and a. So negative 2 is the b value. Negative 1 is the a value. A minus minus 2 becomes plus plus. You end up with a positive 2 over a negative 2, which means that your vertex x value is negative 1. Now, once you have that vertex x value, you need the y value. How do you do that? You simply plug it in and work it out. So you really have y equals negative x squared minus 2 times x minus 1. And I hope you notice that I use parentheses instead of x's. That way I could safely plug in my negative 1 right in there. Let's do the math. Negative 1 squared, that's positive 1. Right? This is where students make mistakes. If you have a minus minus, you change the plus plus only when you don't have exponents. The minus minus rule comes from a negative times a negative equals a positive. And we know we have to do exponents before multiplying. So please do negative 1 squared first, get a positive 1, then take that negative sign and bring it down in front, bringing it back to a negative 1. And then you have negative 2 times negative 1, which is positive 2. Bring down that minus 1 at the very end. And then minus 1 plus 2 minus 1 equals what? 0. So our vertex x value was negative 1. Our vertex y value is 0. That's the most important point on the parabola. Let's go to that coordinate, negative 1, 0. Put a huge dot right there. That's the coordinate, negative 1, 0. What's step 2 when we graph? What's step 2, guys, after doing the vertex?
The line.
Draw the line. What's it called? Axis of symmetry. Okay. After that, you need more coordinates. So you could either use an XY table, do some inputs and outputs, or use the pattern 1, 1, 2, 4, 3, 9. So if you're going with the pattern, I would write it down somewhere. Does this parabola open up, or does it open down?
Down.
Why down?
Because the y
value. A value is negative. A value is negative. So we're going to go 1 over, 1 down. We're going to put a dot right there. We're going to go 2 over, 4 down, 1, 2, 3, 4, put a dot right there. And of course, if we go over 3 and down 9, we're going to be off the graph, so I'm not even going to bother doing that. But I am going to map those coordinates over to the other side. What do I mean by map them? It's 1 unit away from the axis of symmetry, go 1 unit away from the axis of symmetry. 2 units away, go 2 units away. And we have our beautiful parabola right there that's opening down. I hope everybody thinks that's pretty easy. You did not have to use this pattern of 1, 1, 2, 4, 3, 9. You could have gone for an XY table, and you could have plugged in some numbers. Like you could plug in 0, and if you plug in 0 into your x's, right, that becomes 0. You end up with a c value as your output, your answer, which is negative 1. So you could have gotten your coordinates by plugging in numbers, doing the math, getting out answers, and you'd see that the coordinate 0, negative 1 is right there. And of course, you map it over to the other side. So it's totally up to you. If you want to use the XY table and plug in a couple of numbers and get out a couple of answers, or use the pattern 1, 1, 2, 4, 3, 9. You can only use the pattern if your a value is 1 or negative 1. If your a value happens to be 2, you'd have to modify the pattern in order to use it. We'll get to that later when we see one of those problems. But in addition to graphing, we're going to have a quiz this Friday. In addition to graphing, you need to state everything that you can. So there's a couple of things I'll be asking you. Obviously, the vertex is one of them. What's another? The domain. What would the domain be of this parabola? X equals all real numbers. If for some reason you just put domain as all real numbers, you only get half credit. You have to state X equals all real numbers. Because the domain are your inputs, the inputs are your x values. How about your range? Well, if the domain are your inputs, your x values, what's the range? Your outputs, your y values. So you're going to say y is what? It's either greater than or equal to or less than or equal to, depending on if it opens up or down. And because it opens down, it will be less than or equal to. And what is that y value of your vertex? So the y value of your vertex is what?
-1.
Here's the x value. Here's the y value. What's the y value of vertex? 0. Now that makes total sense, guys. I don't know if you guys are getting confused about this. Here's the y value of 4. Does this parabola go up to 4? No. Here's a y value of 3. Does it go up to 3? No. Where does it go up to? It goes up to here. This y value is what? 0, right? So you're down here at -5, 4, 3, 2. It gets up to 0, and then it goes back down into the negatives. So the maximum value is at y being 0. So your whole parabola has to be at 0 or below 0. That's why the range is y is less than or equal to 0. Does that make sense to everybody? Yeah. Again, these are things you should already know. We've been doing this for a couple of weeks already. A couple other things I could ask you. X-intercept. That means where this parabola crosses the x-axis. Where does it cross the x-axis? Actually, I shouldn't put it yellow. X-intercept. I usually do my y-intercept in yellow. Where does this parabola cross the x-axis? At -1, right? Here's the x-axis. It crosses at -1 on the x. So you could say, you could give me the coordinate -1, 0, or you could just say -1. The x-intercept is -1. How about the y-intercept? I usually do y-intercept in yellow. It's also -1. It's right here, right? You could set x equal to 0 and solve. So if you set x equal to 0 and solve, you're going to end up with a c value of -1. So that's also -1. So as you can see, the x-intercept's -1, the y-intercept's -1. And that's about all I could state. Oh no, the axis of symmetry also. The axis of symmetry, we already know that it's this vertical line right here, but I need the equation. You're going to get a point for stating the equation of that vertical line. What is that equation? X equals what? Come on, guys. This is like a free point right here. X equals -1, right? This green line, it's not at 3, right? Here's 3. It's not right here. It's not at 2. It's not at 1. It's at -1. So all you have to state is X equals -1, and you'll get 1 point just for stating that axis of symmetry. There's a lot of free points on the quiz this Friday. What do I mean by free points? Like, I'm going to ask you for the domain. Everybody knows the answer. It's X equals all real numbers. Axis of symmetry is really simple. So there's a lot of easy points on Friday's quiz. Moving on to today's lesson. Today we're going to learn about vertex form equations. Now we already know standard form, y equals ax squared plus bx plus c. We already know that a is a number, b is a number, and c is a number, right? And we know that if I give you this equation, you start graphing by finding the vertex. And how do you find the vertex? By using the formula, and so on and so on. We did that on the class opener. Now, this new form, vertex form is the way it's organized. So if you see an equation that's organized like this, by the way, you need to memorize this. Y equals a parenthesis x minus h close parenthesis squared plus k. If it looks like this, you're going to be able to see the vertex without doing any math. You're going to love this. You're going to love it, right? Let's go over the details here of this. A is just a number. H is just a number. K, they're all just numbers. A, H, and K, they're all just numbers. Just like over here, A, B, and C were just numbers. Okay. Now the A value over here told you a lot. It told you if it opens up, if it opens down, if it's wide, if it's narrow. Again, the closer the A value is to 0, the wider it gets. Also, if your A value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. This A value is the same exact thing. It tells you the same exact thing. If it's positive, it opens up. If it's a negative, it opens down. Same exact A value is over here. All right, so we're good there. The only difference is H and K. H is a number, K is a number, and we need to recognize that H and K are our vertex. Check this out. The vertex is H comma K. Underline that right there, guys. The vertex is H comma K. So H is a number, K is a number, and if you find those numbers, that'll be your vertex. So you could find the vertex without doing any math. You don't need a formula. You don't need a calculator. All you do is look at it and you'll know your vertex. It's amazing. All right. There is one catch to it, and I would like you to underline this also. When identifying your H value, think opposite of what you see. So this minus sign right here is telling you to think opposite of what you see. So if for some reason you have a -3, your H value will be +3. If you have a +7, your H value is going to be -7. All right, so always think opposite of what you see here. So, and the rest is the same. Once you find the vertex, the rest is the same. You either use a pattern or an XY table or a modified pattern. So the only difference between standard form and vertex form, besides the way they look, is that just by looking at it, you can see your H and K value, and that's your vertex. Over here, you have to do the formula. You have to do a lot of math, a lot of opportunities for mistake. Right here, you just look at H and K, you have your vertex. So let's first start by practicing that most essential skill, stating the vertex. So on number 1 right there, now let me rewrite what you need to memorize. Here it is. Y equals A, open parentheses, X minus H, close parentheses, squared, plus K. Plus K. That's what we need to memorize, okay? The H value is always going to be inside of the parentheses with X. The K value is always going to be on the outside of the parentheses, either added or subtracted. The H value, you always think opposite of what you see. The K value, you always take it for what it is. So ladies and gentlemen, what's the H value of number 1? 7. And the Y value, the K value is 0. So the vertex, everybody please jot this down as your answer, +7, 0. Why? Because you have to think opposite of what you see right here for the H. And the K value is what's being added or subtracted over here at the very end. And there's obviously nothing there. So that's why the K value is 0. Again, H is the X value of your vertex. K is the Y value of your vertex. Think opposite on H. Take K for what it is. Are you with me? All right. Number 2. What is the vertex there? The vertex is the coordinate -3, comma, -8. Remember, think opposite on H. Take K exactly for what it is. So yeah, right here, instead of +3, you put a -3. Right here, instead of, -8, you take it for what it is. Just leave it -8. Let's move on to number 3 over here. Now 3 requires a little bit of imagination, right? Because our vertex form equation, Y equals A, has parentheses with the X in there, and then the -H, and then the square, and then the plus K. Exactly. So if you don't have parentheses, let's pretend that there are some parentheses just around the X. That way, you'll still have a square on the outside of the parentheses, like we do up here on our form. There's a square on the outside. And the A value happens to be 2/3. But what's important here is identifying the H and the K. Obviously, the K is 5, but the H is what's being added or subtracted inside parentheses with the X. So since there's no number in there, does it say X -1 in here? No, does it say X -2? It's just X -0, right? So the H value is actually 0. The H value in there, what's being added or subtracted in there is nothing, right? There is no X +2 or X -3. There's nothing. So what represents nothing? 0. So our vertex is the coordinate 0 because there's no number inside the parentheses with the X, and the K value is 5. So 0, 5 is our vertex. What do you think? Easy peasy. Let's go to number 4 here. 4, -1. 4, -1. You think opposite on H. There's a minus sign. It's going to be +4. And you take K for what it is. That's a -1. So you guys should love vertex. Now, stop looking at your paper and just look at the board here, because I made some more just for more practice, more fun. Let's look at number 5 here. What's the vertex right there? +1/2 and 1. Right? Easy. How about number 6? Nathan, help me out here. What's the vertex right there?
-2, 9.
-2, -9. That's right. Opposite on this guy, take that guy for what it is. Ricky. What's the vertex right there? 1/5 and 1/2. You think opposite on the negative 1/5, so it's positive 1/5, and the plus 1/2 you leave it for exactly the way it is. All right, Enrique, what's the vertex right here? You could read it. Come on. 23. Yes, 23. And what's the k value?
0.
Negative 25. Guys, all I'm asking you to do is to find this number, think opposite, find that number, take it for what it is. It's that simple, guys. If you're not paying attention, there's no way you're going to get this. But this is so easy. It's ridiculously easy. We need to pay attention. We're going to have a quiz on this stuff Friday. All right. So that's finding the vertex. Now, how does that make our lives a lot easier? Because what are the steps to graphing? In any form, you got to find the vertex. And then after that, you draw the axis symmetry. And after that, you use a pattern or modified pattern or XY table. And you graph your parabola. So check out how awesome, how easy this is going to be. Let's look at this first one right here. Step 1 is to find the vertex. Could somebody tell me the vertex? 1, 3. Easy. No math, no formula, no mistakes.
Wait, you can just write it, like all of them?
On anything that has parentheses with the square on the outside of the parentheses, you could think of it as vertex form and you could identify H and K. Let's graph 1, 3. Here it is. What's step 2 after you identify the vertex? Yeah, let's do the shortcut. So let's draw our axis of symmetry. So you can, if you wanted to, use an XY table, right? Like plug in 0, plug in -1, get out some answers, map them over to the other side. But since the A value is -1, everybody knows that the A value is -1, right? So we could use the pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. So from the vertex, I want to go 1 over, 1 down. Why am I going down? Because the A value is negative. If it were positive, I'd be going up, but it's going down because it's negative. So 1 over, 1 down. Let's put a dot right there. Go back to the vertex. Let's go 2 over, 4 down. 1, 2, 3, 4. Let's put a dot right there. Go back to the vertex and go 3 over, 9 down. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. I'm off the graph. So I don't really need to put this dot down here because it's kind of pointless. Anyways, now let's just map it over to the other side. So each one of these, 1 unit away, go 1 unit away this way and put a dot right there. Whoops, there you go. And then let's go 2 units away from the axis of symmetry, go 2 units this way and put a dot right there. Now we already know that this one's off the graph. If you wanted to, you could map it over to the other side, but you don't have to, right? Put it right there. Anyhow, let's graph our parabola. I'm just going to put an arrow pointing at that dot. And over here on this side, same deal. Put an arrow pointing at that one right there. So I'm done. I graphed it. It's really easy. I didn't do any math. I did not do any math to graph this. You guys should be loving this section. Now, there are other things on the quiz this Friday that I want to ask you, right? You're going to get several points for graphing this correctly, but then there's a whole list of things that I want to be asking you. Like, for example, what is the axis of symmetry equation?
1.
So you have to give me an equation. It's x equals 1, right? That's another point right there. How about domain?
X equals R.
X equals all real numbers. If you just say all real numbers, you only get half credit. You have to say x equals because the domain are your inputs, which are your x values. The range, what do we say for the range? Y is
3.
Is it greater than or equal to? Or is it less than or equal to? It's less than or equal to because the parabola is going down, and it's less than or equal to the y value of your vertex. What's the y value of vertex? 3. There it is. So you get another point for this, another point for this. There's a couple other things I could ask, like what's the y-intercept? Well, you set x equal to 0 and solve, or you could just see where it crosses the y-axis, which is right here at 2. So the y-intercept is 2. And I could also ask you for the x-intercepts. Now right here,
negative 0.5.
Approximation. So the x-intercepts is 1, 2, not quite 3, so it's less than 3. 2.9, 2.8. All right, so I'm going to put 2.8. And on the negative side,
negative 0.9.
Negative 0.9, negative 0.8, right? It doesn't really matter as long as you're close, I understand. So those are all the possible different things I could ask you. I will ask you on the quiz Friday. So look at all those points. You got a point for axis of symmetry, point for domain and range, 2 points for domain and range, 1 point for the x-intercepts, definitely a point for the vertex, and of course several points for graphing this correctly. But my point is this new form, vertex form, is amazing. It's easy, it's so quick compared to using the formula for the vertex. All right, so right here, guys, what is my vertex?
0, -5.
0, -5. Now, you didn't have to think of this as vertex form. You didn't have to think of the parentheses. You could have thought of it as standard form, right? What's standard form? ax squared plus bx plus c, and you're like, oh, there is no bx, which means that the b value is 0. So if you plug it into the formula, negative b over 2 times a, you'd have negative 0 divided by 2 times 1, which is 0 divided by any number, still 0. You'd get the x value of 0. You plug that back in, find the y value of -5. But obviously, looking at it, h and k is a lot faster, right? Anyhow, we need more points, so I could go to an xy table, or I could use the pattern. Let's graph the vertex first, 0, -5. It's way down here. Axis of symmetry is the line going right through it, the vertical line going right through it. I need more points. What do I do? Shortcut. Pattern. What's the pattern? 1, 1, 2, 4, 3, 9. Okay, so from the vertex, I go 1 over, 1 up. I put a dot right there. Go back to the vertex, go 2 over, 4 up. 1, 2, 3, 4. Put a dot right there. Go back to the vertex, go 3 over, 1, 2, 3, 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, way up there. By the way, why was I going up instead of down?
Because it was positive.
Because the a value is positive, that's right. Let's map over the coordinates to the other side. This one's 1 unit away, this one's 2 units away, this one's 3 units away. Once again, 1 unit is right there, 2 units, 2 units, 3 units, 3 units. Connect your dots, and you have a nice, beautiful, perfect parabola. Whoops, went a little crooked right there. Sorry. Not so perfect. And of course, you could state everything you possibly can. How about x-intercepts? Let's start with x-intercepts this time.
Like 2.3.
2.3, that sounds good to me. About 2.3.
-2.
And -2.2. That sounds good to me. Those are good coordinates, right? 2.3 because 1, 2, it's a little bit more than 2, 2.3. And -2.2, -1, -2, -2.2, not quite 3. All right. So what else could we state? The y-intercept. What's the y-intercept? -5. It crosses the y-axis at -5 right here. We still need the axis of symmetry, and the axis of symmetry... Axis of symmetry. What is it, Enrique? X equals 0. X equals 0. We have to put the x equals when you want to describe a vertical line. X equals and just the x value of 0, right? And that's about it. No, domain and range. Ridiculously easy. Domain is what? X equals all real numbers. Range. Y is greater than or equal to -5. If you put y equals -5, that's technically not right. You have to say greater than. Why is it greater than? Because it's opening up. It's above the -5 value. All right, how about this guy right here? Vertex, what is it? -3, -5. Everybody graph that. -3 on the x, -5 on the y. Right here. What's step 2? What's step 2? Axis of symmetry. And then after that, step 3 is either use an XY table or use your pattern, right? So what do you guys want to use, the XY table or the pattern? Pattern. 1, 1, 2, 4, 3, 9. So from the vertex, am I going to be going up or down? Up, because the a value is positive. So 1 over, 1 up, that's the 1, 1 part. And then we go back to the vertex and go 2 over, 1, 2, 3, 4 up, put dot right there. Go back to the vertex, go 3 over, 1, 2, 3, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. Map those coordinates over to the other side. Make sure they're equally spaced from the axis of symmetry. Actually count 3 units, 3 units, 2 units, 2 units, 1 unit, 1 unit. And you have your amazing, perfect parabola. So you get several points for that on the quiz Friday. And then all the other points come from knowing everything about this parabola. The domain, x equals all real numbers. That's one answer. The range, y is greater than or equal to the y value of your vertex, -5. That's another point right there. How about y-intercept? It crosses the y-axis where? At 4. Or, no, is it 4?
0, 1, 2, 3. Yeah, 4.
Did I mess up on this?
No, it's at 4.
It's at 4.
It's at 4.
No, 1.
It's at 4. The y-intercept is at 4. 1, 2, 3, 4. Now, some of us are so used to thinking, actually me, I'm so used to thinking of standard form that I see the c value and I want to say, oh, it's going to cross at -5. But this is not in standard form. This is vertex form.
Okay, the vertex is wrong.
So check this out, guys. If you wanted to set x equal to 0 to solve, you'd have 3 squared, which is 9, and 9 take away 5 is 4. It's obviously easier to just look at where this crosses the y-axis. That's the location of 4 on the y-axis. How about the x-intercepts?
-0.75 and -5.1.
I like that. -0.75. And what was that?
-5.1.
-1, 2, 3, 4, 5.1, -5.2. Those are both good values. -5.2. And that's everything you could say about this parabola. Oh wait, the axis of symmetry once again. So how about the axis of symmetry? What is it?
-3.
You can't just say -3.
Oh,
X equals -3. So we get all kinds of points for knowing all these details. Moving on to this next one. What's the vertex right here?
-1 or 0, -1.
0, -1. Okay? Because if you think about parentheses around the x, the h value is definitely 0 because there is no number being added or subtracted inside parentheses with x. But the k value is -1. You take that k value for what it is. So 0, -1 is the vertex. Is this opening up or down? Down because the a value is negative, which means that if we use the pattern 1 over 1 down, you'll end up right here, and then you go back to the vertex 2 over 1, 2, 3, 4 down, you'll be on the edge. And obviously, if you go 3 over 9 down, it's going to be way off the graph, so I'm not going to do that. I forgot to draw my axis of symmetry. Here it is. Map it over to the other side, and there's your perfect parabola opening down. So let's state everything that we can right here on this parabola. So how about the domain?
X equals all real numbers.
How about the range? Y
equals, or y is
less than or equal to -1. How about the y-intercept? Where does it cross the y-axis?
at -1.
At -1. How about the x-intercept?
0.
Now, if you say 0, that means that the parabola touches the x-axis right at 0.
Is not.
No, I thought it was.
Oh wait, this will work.
So the x-intercept is none. There are no x-intercepts. Or you could put like a NA, not applicable. Or you could say does not cross. Can't spell what? Can't spell cross. Cross. X-axis. You could, I mean, whatever. I need to know that you know that it doesn't cross the x-axis, right? The parabola is opening down. It never reaches the x-axis. It never crosses the x-axis. Sometimes it'll touch once. Sometimes it'll cross at two locations, or it might not cross at all. Yeah, the axis symmetry, final detail. A of S. What is the axis symmetry?
Negative, or just 0.
You got to give me something. X equals 0, right? You have to say x equals to get that vertical line. Last one. Vertex.
1, 0.
-1, comma 0. That'd be sad if we put 1, 0, then the whole thing's wrong after that, even if we do everything right. So think opposite on H, take K for what it is, which there is no K, so that's why it's a +0 out there. So let's go to the coordinate -1, 0. There it is. Let's draw our axis of symmetry right through it. There it is. Let's get more coordinates using the pattern 1, 1, 2, 4, 3, 9, 1 over 1 down. Put a dot right there. Go back to the vertex 2 over 4 down. Put a dot right there. And we already know that if we go back to the vertex and go 3/9 down, we're going to be off the graph, so I'm not even going to bother doing that. But I do map it over to the other side, and I have my amazing, beautiful parabola without doing any math. So vertex form is way better than standard form when it comes to graphing by hand. Anywho, this guy, the domain, what is it?
All real numbers.
X equals all real numbers. The range,
R is less than
y
or,
is
oh wait, yeah, Y is less than or equal
less than or equal to what?
to 0.
The y value of your vertex, which happens to be 0. How about the y-intercept? What's the y-intercept? Where does it cross the y-axis? At -1. How about the x-intercepts?
None. Or yeah, no.
It actually, it doesn't cross at 2 locations. It only touches at that one location of -1. And final thing I could ask you is the axis of symmetry equation. X equals -1. And that's it. We are done. There's homework on the back side. Let's get busy on it.